Jupiter has captivated humans for centuries. The largest planet in our solar system harbors many mysteries beneath its colorful cloud tops. This gas giant holds secrets we are only beginning to uncover. From its raging great red spot to its hidden core, Jupiter is a world of extremes. What astounding revelations lie in wait within its turbulent atmosphere and mysterious moons? Let's explore the enigmatic giant of our solar system. You see, unlike Mercury, Venus, Earth, and Mars, Jupiter is a gas planet, meaning a large portion of its composition is gas. With its tremendous size, Jupiter easily falls into the category of a gas giant. Although it is a gas planet, Jupiter isn't merely a big cloud of gas that you could just fly through. A more fitting description for the planet would be a fluid planet that gets denser and hotter the deeper you go. The pressures present at the vibrant cloud tops of Jupiter bear some resemblance to those observed in the atmosphere of Earth, but as you go deeper into the planet, like a submarine going into the depths of the ocean, these pressures increase slowly. In 1610, Galileo's discovery of Jupiter and its 4 significant moons, namely Io, Europa, Ganymede, and Callisto, played a pivotal role in revolutionizing our comprehension of the universe and our place within it. In fact, it was the first time that astronomers observed celestial bodies orbiting an object apart from Earth, which supported the Copernican view that Earth was not the center of the universe. It was a groundbreaking observation that challenged the prevailing geocentric model and introduced a new era of understanding the cosmos. Cut to 400 years later, and with centuries of advancements in technology, NASA's Juno mission reached Jupiter in 2016. It was originally planned to stay in orbit for about 20 months, but as of 2023, it is still going strong, providing beautiful images, audio, and other data. The mission has been extended until 2025. Out of the 9 missions that have explored Jupiter, only 2, namely NASA's Galileo and Juno, have successfully orbited the planet. Others, such as Pioneer 10 and 11, Voyager 1 and 2, Ulysses, Cassini, and New Horizons, have passed Jupiter, providing valuable information. There were unique discoveries about Jupiter made by each mission. Pioneer 10 and 11 showed the dangers of Jupiter's radiation belt and studied the Great Red Spot and the polar regions. Voyager 1 and 2 made maps of Jupiter's moons and found sulfur volcanoes on Io, discovered Jupiter's rings and found lightning in its clouds. Ulysses showed how the solar wind affects Jupiter's magnetosphere. New Horizons took pictures of Jupiter and its biggest moons from close up. The first orbiter, called Galileo, arrived in 1995 and sent a probe into Jupiter to get information about its atmosphere and chemicals. After studying Jupiter's system for 8 years, it consciously crashed into the planet to avoid contaminating Jupiter's moon Europa. From a polar orbit, Juno studies Jupiter to learn more about the solar system's formation and the development of alien planetary systems. Data from the mission suggests that Jupiter's core might be larger than expected and that its storms and stripes extend deep into the planet's interior. There aren't any specific missions planned for Jupiter, but 2 upcoming spacecraft, NASA's Europa Clipper and the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, will be devoted to examining the planet's moons. On July 14, 2022, the James Webb team released captivating photos of Jupiter during its commissioning period, which showed Jupiter's thin rings and its moons Europa, Debe, and Metis through James Webb's NIRCam. These missions have extensively helped scientists and astronomers understand our neighborhood gas giant even further. Jupiter is known for having a mass that exceeds the combined mass of all the other planets by more than 2 times. Its sheer volume is so great that it could contain over 1,300 Earths. Earth would be no larger than a grape if Jupiter were the size of a basketball. Jupiter has a diameter of 43,440.7 miles or 69,911 kilometers, making it about 11 times wider than the Earth. Jupiter is about 5.2 astronomical units away from our star, which is 484 million miles or 778 million kilometers away on average. For those of you who didn't know, an astronomical unit is the distance from the Sun to Earth, and at this distance, It takes 43 minutes for sunlight to travel from the Sun to Jupiter. That's almost about the average lunch break around the world. The moment when Jupiter is closest to the Sun, known as perihelion, sees it reach 460 million miles or 740 kilometers from Earth. On the other hand, at aphelion, the point in Jupiter's orbit that is farthest from the Sun, the planet is located approximately 507 million miles or 816 kilometers away from the Sun. The first planet to form in our solar system is likely Jupiter, which is likely a result of the leftover gases from the Sun's formation. NASA explained that Jupiter could have evolved into a star if it had been around 80 times more massive during its formation. That would be both fascinating and terrifying at the same time. What's really interesting, though, is that Jupiter has the shortest day of all the planets in the solar system, only taking about 10 hours to complete one rotation. However, it takes about 12 Earth years or 4,333 Earth days for Jupiter to complete its full orbit around the Sun. This is 1 year in Jovian time. Another interesting fact is that Jupiter's equator is tilted only 3 degrees when it revolves around the Sun. This makes it spin almost upright. Because of this, Jupiter doesn't have as extreme seasons as other planets. It is believed that Jupiter formed around 4.5 billion years ago, when gravity pulled in swirling gas and dust, creating this massive gas giant. After the Sun's formation, it accumulated most of the remaining mass, making it more than twice as massive as all the other bodies in the solar system combined. Even though Jupiter shares the same chemical makeup as a star, it was not sufficiently massive to ignite and become a star in its own right. Around 4 billion years ago, Jupiter settled into its current position as the 5th planet from the Sun in the outer solar system. Jupiter is mostly made up of hydrogen and helium. Similar to that of the Sun, as we enter its atmosphere, the pressure and temperature increase, transforming hydrogen gas into a liquid state. This creates the largest ocean in the solar system, which is made of metallic hydrogen instead of water. Jupiter can be pictured as an enigmatic expanse resembling a vast ocean, brimming with a variety of unusual and exotic elements. At depths about halfway to the planet's center, scientists believe that the pressure becomes so intense that electrons are squeezed off hydrogen atoms, which turn the liquid into a metallic form. Jupiter's rapid rotation is thought to have created electric currents in this area, which led to the creation of its strong magnetic field. But the details of Jupiter's core are still unknown. It might have a solid central core or a thick, super hot and dense mixture of both. The temperature down there could reach as high as 90,032 degrees Fahrenheit or 50,000 degrees Celsius, and it's mostly made up of iron and silicate minerals similar to quartz. You know, the stuff that makes up cement, fiberglass, ceramics, and a bunch of other things. Jupiter is a gas giant, so it doesn't really have a solid surface. It's mostly made up of whirling gases and liquids. A spacecraft can't land on Jupiter, and trying to fly into it would be very dangerous. That might actually be an understatement. Any spacecraft attempting to reach the interior of Jupiter would be crushed, melted, and vaporized by the intense pressures and temperatures there. The bright and dark spots on Jupiter are caused by fast winds that blow from east to west in its upper atmosphere at speeds of over 335 miles per hour, or 539 kilometers per hour. The light zones have white clouds made of frozen ammonia crystals, and the dark zones have clouds made of other chemicals. Even further within the atmosphere, we find blue clouds. These cloud bands are not static. They undergo changes over time. There may be diamond rain in Jupiter's atmosphere. You heard that right, diamond rain. Interestingly, as much as 10 million tons of diamonds may be stored on Jupiter, which sounds like a dream. Let's just say that would make you a whole lot of money. But considering their abundance, diamonds wouldn't be as rare and expensive. But you'd still make a ton of cash. But I digress. Jupiter has a very strong magnetic field that is much stronger than any other planet in our solar system, nearly 20,000 times stronger than the Earth's magnetic field. The magnetic field creates a strong belt that traps electrons and other charged particles. These particles produce radiation that is more than 1,000 times more harmful to humans This means that Jupiter's moons and rings are regularly bombarded by this radiation. Even spacecraft that are heavily protected, like NASA's Galileo probe, can be damaged by it. The magnetic field of Jupiter extends from the planet towards the Sun, spanning a distance of 600,000 to 2 million miles or 1 million to 3 million kilometers. It also extends beyond the planet, spanning a distance of 600 million miles or 1 billion kilometers in a tail-like structure. One of Jupiter's most distinct and renowned features is the Great Red Spot, a massive hurricane-like storm that has lasted for more than 300 years. According to NASA, the Great Red Spot is twice the size of Earth at its widest, and its edge spins counterclockwise around its center at speeds of about 270 to 425 miles per hour, or 430 to 680 kilometers per hour. Its counterclockwise spin makes a type of storm known as an anticyclone. The color of the storm, which usually varies from brick red to slightly brown, may be caused by small amounts of sulfur and phosphorus in the ammonia crystals in Jupiter's clouds. The spot has been shrinking for some time, although it appears that the pace has slowed down recently. Jupiter has many other storms too, according to 2022 data from Juno. Jupiter's gargantuan polar cyclones are driven by convection or heat rising from lower altitudes to the higher atmosphere, similar to the way ocean vortexes are driven by convection or heat. Jupiter has a mind-boggling 79 known moons, mostly named after the paramours and descendants of the Roman god of the same name. That's way too many moons, if you ask me. I think this sums it up best. Anyway, Galileo Galilei discovered the 4 biggest moons of Jupiter called Io, Europa, Ganymede, and Callisto. Because of this, they are sometimes called the Galilean moons. Ganymede is the biggest moon in our solar system. It's even bigger than Pluto and Mercury. It is also the only moon known to have its own magnetic field, whose eerie sound NASA's Juno mission captured in 2021. It has at least one ocean between layers of ice, although according to a 2014 study from the Journal of Planetary and Space Science, it may contain several layers of ice and water stacked on top of one another, along with atmospheric water vapor, first spotted in 2021. The European Jupiter Icy Moons Explorer spacecraft is scheduled to launch in 2023 and reach Jupiter's system in 2030, with Ganymede as its primary target. Io is the most volcanically active body in our solar system. As Io orbits Jupiter, the planet's massive gravity causes tides in Io's solid surface that rise 300 feet or 100 meters high and create enough heat to start volcanism. Those volcanoes release more than 1 ton of material every second into the space around the moon. This helps to make strange radio waves from Jupiter. The sulfur from its volcanoes gives Io a blotchy yellow-orange appearance, kind of like a pepperoni pizza. The frozen crust of Europa is largely composed of water ice, and it may conceal a liquid ocean that contains twice as much water as Earth's ocean. Some of this liquid comes out of Europa's southern pole in sporadic plumes, and in 2021, the Hubble Space Telescope spotted more water vapor above the surface. Also, in 2021, Europa's North Pole was photographed for the first time, and the discovery of underwater volcanoes raised hopes that Europa could be hospitable to life. NASA, with the National Oceanic and Atmospheric Administration and the Woods Hole Oceanographic Institute, may one day send an autonomous submersible to explore Europa's ice-covered oceans. NASA's Europa Clipper mission, which would launch in 2024, would also fly by the icy moon 40 to 45 times to see if it could be habitable. Callisto is the least reflective of the 4 Galilean moons. This suggests that its surface might be made of dark, colorless rock. NASA believes Callisto, once viewed as a dull alternative to the other Galilean moons, may actually contain a mysterious ocean, according to the agency. We have another video about the moons Europa, Ganymede, and a few others and their possible habitability, which you can check out in the description. Be sure to subscribe, and don't forget to watch that one too, but only after you're done with this one. Yup, Jupiter does have rings. NASA's Voyager 1 spacecraft made an unexpected discovery in 1979. Jupiter has 3 faint rings encircling its equator. Unlike Saturn's large, colorful rings, Jupiter's rings are much thinner and composed of continuous streams of tiny dust particles emitted by some of the planet's moons. According to the Southwest Research Institute's Juno mission website, the main ring is flat and about 20 miles or 30 kilometers thick and over 4,000 miles or 6,400 kilometers wide. Next, there's an inner donut-shaped ring known as the halo, which is more than 12,000 miles or 20,000 kilometers thick. Electromagnetic forces push dust grains away from the main ring, creating a halo effect. Both the main ring and the halo are composed of small, dark dust particles. The third ring, called the Gossamer Ring, is transparent and is made up of 3 rings made of debris from Jupiter's moons, Amalthea, Thebe, and Adrastea. Researchers believe the Gossamer Ring is composed of tiny dust particles, similar to those found in cigarette smoke. It stretches from an outer edge about 80,000 miles or 129,000 kilometers from the planet's center to an inner edge about 18,600 miles or 30,000 kilometers inward. It plays a vital role in shaping the destiny of our cosmic neighborhood, thanks to its incredibly strong gravity. Researchers have found that Jupiter's gravity is what keeps planets like Neptune and Uranus, as well as smaller objects like asteroids, away from the Sun. This concept is commonly referred to as the Nice model, derived from the city in France where it was initially developed. This model says that gas giants like Jupiter were also involved in the late heavy bombardment, a period when Earth and its neighboring planets were bombarded with debris. I'm glad that Jupiter's looking out for us. In the present era, Jupiter serves as a safeguarding agent for the inner planets, such as Earth, by posing a potential threat to the collision of asteroids and comets with them. Scientists refer to Jupiter as the vacuum cleaner of the solar system, due to its immense gravity, which has the ability to either capture and absorb smaller objects or completely eject them from the solar system. But this same powerful gravity can also accelerate some objects towards the inner planets, making it a double-edged sword. For instance, in 1994, the gravitational pull of Jupiter resulted in the dazzling collision of comet Shoemaker Levy 9 with the planet. That's pretty scary, but it's a relief to have Jupiter on our side. The short answer to this question is that it's unlikely. Jupiter's atmosphere becomes warmer with depth, reaching room temperature, or 70 degrees Fahrenheit or 21 degrees Celsius, at an altitude where the atmospheric pressure is about 10 times as great as it is on Earth. Scientists think that if Jupiter has any kind of life, it would have to be airborne at that level. According to a 2021 study, there is enough water to support some form of life, but researchers haven't found any evidence of life on Jupiter. Jupiter's moons are a different story. Europa in particular could host a radiation-shielded hidden ocean, and marine life might float somewhere in those alien waters. As massive as Jupiter is, it's drenched in mystery. While there's a whole lot we already know about our neighborhood gas giant, there are some key details we don't know, like the nature of Jupiter's core, or where its magnetic field originates, among numerous other questions. Scientists and researchers have been tirelessly working to answer these questions with the data we currently have, the rise of the James Webb Telescope, and future missions like NASA's Europa Clipper and the European Space Agency's Jupiter Icy Moons Explorer. We'll be able to know more. But until then, let's admire this incredible planet and its unique attributes. Jupiter is truly the king of planets. Thanks for watching. What more do you think we'll find in the atmosphere of Jupiter? And do you really think Europa and Ganymede could support life? Let us know in the comments below.